Now let's look at how to take derivatives of the other trigonometric functions other than sine of x and cosine of x using the information we already know about the derivative of sine of x and the derivative of cosine of x. The first thing we're going to do is rewrite all our trigonometric functions in terms of sine x and or cosine x. So here's our list of our 4 other trig functions. Tangent of x is sine over cosine, secant is 1 over cosine, cotangent is cosine over sine, and cosecant is 1 over sine. And we see that all 4 of these are division of trig function sines and cosines. So now we can apply what we know about the quotient rule to determine the derivative that we want. Let's start by looking at the derivative of the tangent of x. So we're going to write the derivative dy dx as the derivative of the sine of x over cosine of x. And here I've kept the sign green so that we can see how we apply the quotient rule in our derivative. So remember, when we take the derivative, we want to take the derivative of the top times the bottom minus the top times the derivative of the bottom divided by the bottom squared. So we have that written out here. So now let's take some time to simplify. We see we have a cosine squared in the top. 2 negatives become a plus sine squared. So we have cosine squared plus sine squared in the top divided by cosine squared. Now remember, our identity says that cosine squared plus sine squared is equal to 1. So we have 1 over cosine squared of x. This, however, can be simplified even further as secant squared. We have 1 over cosine times 1 over cosine, so we have a secant squared. So the derivative of tangent x is secant squared x. Let's do one more. What about the derivative of secant? Now, in this case, I want to apply a multiplication rule by rewriting our secant fraction and bringing the denominator up and raising it to the negative 1 power. So this is one of our ways that we talked about finding the derivative when we have a quotient. So in this case, I'm going to apply the chain rule by first taking the power down, minus 1, taking cosine of t and raising it to the new power, to the minus 2, and then multiplying by the derivative of cosine, which, as we remember, is minus sine of t. Now we want to simplify this. We have 2 negative signs. It becomes positive. And we have a sign on the top, and I'm going to pull that negative exponent down into the bottom and make it cosine squared in the denominator. Now we can simplify this even further by recognizing that this can be written as a 1 over cosine times a sine over cosine, and 1 over cosine is secant, sine over cosine is tangent, so the derivative of the secant is equal to the secant times the tangent. You can do the same thing for cotangent and cosecant of x.